Now I would like to invite Autodesk Senior Technical Manager, Neil Brooker. Neil, stage is yours. Teşekkürler.
Günaydın. Ladies and gentlemen, an honor to be here. That is the limit of my Turkish, I'm afraid. It's not strictly true. One of the only interesting things about me is that a few weeks ago I got married to a Turkish lady. So, thank you. From Samson. No, okay. She's slowly teaching me some basic Turkish to, make my life easier, important phrases for work and living. And she's teaching me the important ones first, so apologies for the pronunciation. Evet, tabii ki sen haklısın hayatım. Yeah? Okay. Saat kaç oldu neredesin? Anyway, there's more to come, I'm sure. They're very important. But anyway, it's a pleasure to be here. As I said, I'm here to talk about a very exciting future for our businesses and for the world in general. It's called the future of making things. And what does that mean? We noticed at Autodesk that there are a few technology trends that are beginning to really disrupt the way that we imagine, create, make, manage things. Everything around us, everything that we build, everything that we do in our lives. I'm only going to talk about 3 of those technology disruptions, as we call them, today. But these are very exciting avenues that we are beginning to go down. So I'm going to talk about cloud computing. I'll talk about the digitalization of everything. I hope I don't have to learn that in Turkish. And I'm going to talk about the very exciting world of machine learning, which includes artificial intelligence and also deep machine learning. So let's start with cloud computing. To put cloud computing in context, let's go back 200 years when the world began to industrialize. Man has created a lot of incredible inventions. We have also created a few that didn't really work out particularly well. But the one thing in common that all of these inventions had was they needed fuel. And back in the industrial age, that fuel was mainly coal. And we used coal to make steam. The steam drove the engines that made the steel and other products, of course. We then had a bit of a boom, and we invented a lot of other good stuff. So we invented railway lines, the electric light bulb, telegrams, so we could interact with each other in a non-WhatsApp, Facebook kind of way. These were all driven by fuel. So what do you think today's fuel is? Any ideas? Well, it actually is data. Data is the fuel that is driving the way that we are beginning to live, create, and manage the world around us. And if you imagine that data is the fuel, then the cloud is the transporter of the fuel. It's the pipeline for the fuel. I'll come back to that picture later. The cloud is pervasive. We live in a cloud-driven world. All of our daily tasks that we do now involve, in some shape or form, cloud technology. So whether it's banking, whether it's Netflix, it's all cloud-based technology. So it's our personal lives as well as our business lives that the cloud is fundamentally changing, and very rapidly. In design, manufacturing, and construction, we can now use the power of the cloud to infinitely increase the productivity and profitability of our businesses. Let's go back to 1982. This is the first, one of the first PCs, personal computers. And on the right there is the first AutoCAD. Now, the personal computer revolutionized our world almost as much as the cloud is doing now. Autodesk saw that with the personal computer, we could democratize technology to put tools into the hands of people that would never use us before, or to put tools into the hands of people who were designers before, but it would increase their productivity and profitability. If you can imagine now that the cloud is actually what the personal computer was back in 1982. I'm not going to tell you what this is, but this is the design of something that I will show later that use the power of tens of thousands of computer nodes in the cloud to create radical advances in design that increased efficiency, strength, profitability, cost to market, all of those things that we care about in business. I'll come back to this. When we think about computers, even today, or the phone that I just showed you to read very bad Turkish off, they're all passive to a great degree. They sit there and they wait for us to push a button or click. They don't do anything really unless we tell them. The era we're moving into now is moving away from the passive computer technology to a more generative computer technology that Emin just touched on briefly in his presentation. Here we have a simple chair. We can design the simple chair. An engineer will sit down, he wants to design a chair, he has an idea, so he creates the design, he might make a mock-up or the first prototype of the chair, and then go back and change and so forth. Similarly with simulation, we can do simulation now on all of the things that we manufacture, but it takes time. Some of the computer programs are very complicated. They need skilled experts to understand the simulations. And of course, again, they need prototyping. This takes a little bit of time and can be very costly. With generative design, we can actually now simulate to discover the design. We don't really need to tell the computer what we are doing. What we do is give the computer some constraints, some parameters and information that the algorithm in generative design will take and create things like this chair here. This chair was designed by a young lady in the United States who had never touched a computer-aided design system before in her life. She worked with an artistic engineer and came up with this beautiful wooden chair, generatively designed by a computer. I want you to take notice of the form of that chair because this becomes important with most of what I will show you this morning. Here's another example from the manufacturing world. This is Lightning Motorcycles, who have created the fastest electric motorcycles in the world. They use generative design on this swing arm part to create something radical, more efficient and more effective. Here's the process. I tell the algorithm the parts that I want to keep, the connectors, and then I run the program with a lot of parameters and constraints. The computer will return to me hundreds or thousands of options for this swing arm within seconds or minutes. I can then look at those and I can decide which ones I want to explore in more detail. But it goes even further than that. Using this technology, we can not just design, but we can find out how to manufacture using the generative design software. So once I have my design, I can look at additive and subtractive manufacturing techniques. I can run simulations on this design to see where all the stresses and strains and maybe where the problems will be. So just using my computer and the power of the cloud, I don't have to go to a factory to create a prototype. I don't have to run expensive simulations in a wind tunnel or anything like that. I can just use the computer itself. And you can see here that we're having a look at how to manufacture this particular part. Again, look at the structure of this swing arm. It looks fairly similar to the chair. And again, I'll tell you why in a second. Generative design is being used increasingly in all walks of manufacturing and construction. Here's a great example from where I live in Dubai. This is the Museum of the Future. It's an absolutely stunning design and will be an icon, I think, as a building. But if you look at that design, it's not very big. It's only 25,000 square meters, and it only has 7 floors. But the design itself is radical, and I think you can agree that if you sat at a computer and tried to design that, it would take you a long time. So how do you engineer such a complex shape? How do you build such a complex building to make it look as stunning as it does? Well, the main contractors on this program, Buro Happold, used a combination of building information modeling, where they connected all of the parts of that building, the concrete, the air conditioning, which is very important, by the way, in Dubai, the elevators, the escalators, the electrics, everything in one centralized model. We've been doing that for a while now. The benefits of digitizing building information modeling are pretty well known. But what Buro Happold did was take it one step further and use computational and generative design on this building. So you can see some of the options for the outside cladding. They ran hundreds of them to minimize the time to completion and to maximize the efficiency of the building. This was all done using generative design algorithms. And what this allowed them to do was to come to a solution for this building where they could reduce the construction cost, they could reduce the materials that they used, and probably most importantly, because this is actually the vision of the ruler of Dubai, they needed to keep into the original design shape. So they needed to be pretty much spot on with the design of the building, the shape of the building, rather. So they got that to within 80%. This is what it looks like a week ago. I took this picture 1 week ago. And you can see the structure inside, how complex that is. And again, it looks a little bit similar to the chair and to the motorbike swing arm. Why is that? I'll come back to that. I keep saying that, but I will, I promise. But not only can we create this beautiful building, but we can simulate the building itself. Using gaming technology, using what we know about human beings, we can run simulations. People have been generating images like this for marketing purposes for a long time. But it doesn't really tell us anything about the operation of this building and how people will interact with it. We've used CAD tools to do the same. It's fine, but there's no real magic here. The magic happens when you include computational algorithms with people's behavior. So here is a simulation of what happens when people come out of the future, of the Museum of the Future from a TED talk or a concert. And you can see automatically that there are certain choke points. The one by the elevator, bottom right, is a particular issue, of course. And of course, people in Dubai love elevators and not so much with the stairs, even though I'm sure there's plenty of them. You can take that further. You can actually analyze how people will behave in certain situations. So here's an example where a bus comes in, puts some visitors off, they go inside the building, and using artificial intelligence, we can simulate how different people act within this space. So some might go to the restaurant, some might go to the restroom, some might go straight into the auditorium to take their seats for the concert or whatever it is. This is much more intuitive, much more effective at managing the interior of the building, and it all comes from connected BIM, generative design, and computational design. And that's what it will look like next year, I believe. Here's another example of using generative design inside the building. This is our new office in Toronto, Autodesk office in Canada. And you can see it looked a bit messy. A lot of engineers doing cool stuff. What we did was we used the new office as a laboratory, as a research lab. We used our staff as guinea pigs, if you like, and we researched their behavior to maximize the benefit of the office space. I'll explain that in a little bit more detail. So we have a 3D model. We can analyze heat, we can analyze cold, we can analyze sunlight. We know all of that stuff. We've been doing that for years. What we don't usually analyze is people's behavior. So we asked our staff in Toronto to give us preferences. Where do they prefer to sit? Near the window, somewhere cooler, near the coffee machine, near the printing machine? Do they want to sit next to Bob, or do they not get on with Bob particularly well? All those kinds of things that we never usually take into consideration when we're arranging facilities management. And the generative design algorithm came back with thousands of options. Let me take you on a glimpse of what might happen in the future. This is like an Amazon Echo for Autodesk. And I'm going to attempt to talk to my computer now. So computer, can you load up the Toronto project, please?
Loading project. Last night, the surveyor updated the laser scans. I have converted the scans to a 3D model.
That's great. Can you show me the second floor, please? And start the space planning.
Here is the floor plan. Space planning tool initialized.
Great. Can you add the outside views as well, please?
Okay.
Great. Now, please bring in all of the preferences from the people in the office.
Okay. Program and survey imported.
Great. Now, can you launch the study and just give me 1,000 different options?
Okay. Starting the adjacency preference, work style preference, buzz, productivity, and view analysis. Estimated time, 6 seconds. Studies completed. Running the daylight analysis. Estimated time, 3 hours. Would you like to see a predictive model that is 98% accurate? Estimated time of predictive model, 7 seconds.
Yes, please. I don't have 6 hours, so please run that.
Okay. Running the daylight predictive analysis. All studies completed.
Okay, great. Could you just give me your top 1,000, please?
Okay. Here is a parallel coordinate plot representing 10,000 designs within the criteria range.
10,000? That's too many for me. Can you just give me the top 10 of your analysis? Okay, thank you. I like the look of number 5 because I like blue. So can you send that to the contractor, please?
Okay. A VR and 3D model as well as 2D documentation have been sent.
Fantastic. So, a little bit far off, on our Toronto office, we used the algorithms. We didn't necessarily do this, but it shows the process of how we can use generative design to really speed up and maximize the benefits inside buildings as well as outside buildings. And this is what it looks like now. You can see it looks like a nice space. And everyone apparently is very happy with their new office. Let's go to outside of Autodesk and have a look at other examples around the world of where generative design is making a big difference. This is Airbus, and Airbus are researching the planes of the future. This is just an idea of what we might be flying in the future. Is everyone scared of heights here? I am. I'm not sure about getting on this, but the idea is wonderful. And again, look at the structure of the outside of the plane. It looks very similar to the chair and so forth. That's because generative design algorithms mimic nature. And if you look at nature, you can see that they're very efficient at creating themselves as strong as possible with very intricate shapes. Not many engineers could sit at a computer and actually design these complex structures, the sort of structures that come from tree roots and coral and so forth. The generative design algorithm doesn't have any preconceptions about what a design should look like, but it learns from nature. So you can see all these structures look very similar, but they are immensely stronger and use a lot less material than traditional design. So Airbus are already using generative design in their new A320neos. They started with this bulkhead where the stewards and stewardesses would sit, and they redesigned it completely. You can see, again, the elaborate lattice kind of structure. They were 3D printed as well, and they're being put into their new fleet. And they estimate that it's the equivalent of taking something like 19,000 cars off the road for every A320 for its lifespan. And actually, if you translate that into a whole fleet of Airbuses, it could be savings to the environment of about 140,000 tons of carbon in the atmosphere over the lifetime of one particular aircraft. So significant environment benefits just by installing one simple bulkhead. And they're working on seats and all the rest of it as well. I mentioned nature. This is an example of how generative design works. This is a slime mold called Posirum. And what Posirum does is, looking for food, it creates a network of itself. And as it goes along, it takes out the weakest links and reinforces the strongest links. And that's exactly what generative design does. What you end up is something that you can manufacture that is cheaper, lighter, and stronger than anything we can imagine just sitting in a computer. Last example is for generative design is a company called Hackrod, who did a lot of research in the Mojave Desert in the US for a radical chassis for a sports car. They put sensors on chassis and on the driver to collect tens of millions of data points. So the data drove the generative design engine. And you can see this image I showed you at the beginning is actually a car chassis. You would never really think that. But again, this is lighter, stronger, cheaper and quicker to build than a traditional car chassis. And that is now inside this sports car. Okay, so that was a little bit about generative design. Let's talk about the digitalization of everything. You saw this picture at the beginning. I was talking about data as a fuel. One thing that is becoming pervasive now in our whole lives is the availability at cheap cost of sensors. We can put sensors anywhere, and we can collect data. Data on its own isn't that powerful unless you do something with it, unless you create more data from that data. So sensors help us do that. Here's an example from the motor industry. Emin mentioned General Motors. This is Tesla. And in 2016, Tesla made a few thousand cars. During the same year, General Motors made 7 million, something in that range. However, the next year, 2017, Tesla's market capitalization, or the value of the company, was for a time greater than General Motors. Why was that? Well, it was because investors saw the value of what Tesla were doing to the consumer. Tesla were not just making vehicles, they were making intelligence. Vehicles that would grow with the user and understand what is going around them and be able to be programmed in the future to evolve. So an evolving car, so something you just don't sit in a traffic jam, but something that will get to know you, your habits, where you go, and so forth. A great example of what they're doing came when one of their cars flipped over. Guy was driving too fast or whatever, flipped over. So what Tesla did, because they had the technology, was to lower every single customer's Tesla overnight, whether they were in the garage or wherever, by about that much. 2.5 inches, that translates to about 5 centimeters. They just did that also. The customers didn't even know, because they had to lower the cars to make them safer while they investigated why this car flipped over. So using digitalization and sensors is really advancing the way we interact with the objects that we take for granted. And cities will become the same. You probably heard about smart cities. Well, smart cities are city information where things interact with other things. The cars can tell the police that there's a traffic jam. The buildings can tell the cars that the car park is full. You can get the weather forecast from cars 50 yards ahead. It's all about sensing data and using that data in an intelligent way to enhance our lives as human beings. Here's some real-world examples of how people are using the digitization of everything with the infinite power of cloud computing. So I'm going to talk about a hydropower station in Norway, the largest one in Norway, called Varma 12. I'm going to talk about a research laboratory in Rotterdam called RamLab, and I'll talk about a little project somewhere around here, just up the road, called Istanbul Grand Airport. I think you've all heard of that. So the first one is Varma 12. As I said, the largest hydropower station in Norway, and it was getting pretty old. It was about 100 years old. So a company called Norconsult took on the project and decided from the start that they were going to use zero paper, they were going to use connected building information modeling, and they were going to use digitalization as their strategy for improving this facility. So they put a building information modeling together, just one centralized model to manage the whole project. They also used computational design to put complex structures like mesh reinforcements inside the water ducts. You can see there. And very importantly, they collected information remotely using sensors, whether it was on drones or cars, to actually manage the construction of the project and to make sure that the new design fit well into the old facility. They used tablets on site. They used no paper at all to create this new design and extend the life of their facility for another 100, 200 years. Moving to Rotterdam, this is the Rotterdam Additive Manufacturing Laboratory. And they're doing a lot of research around additive manufacturing and computer-aided manufacturing by using digitization techniques. So what happens in the shipping industry today is that if a part breaks, for example, if this propeller or one of its blades breaks, the ship has to go into a dry dock. They have to go to an inventory of parts if they have it, or they have to get it made off-site somewhere. In the world today, shipping inventories are unused. 70% of them are unused. They just sit there. So that's expensive for a start. They're never used at all. If you have to order off the shelf, it's going to take weeks, so your ship is sitting doing nothing for weeks. So what RamLab are doing are just using computer-aided manufacturing and additive manufacturing. They're collecting information about the parts that need to be replaced. They're modeling them, and they're making them using additive and subtractive manufacturing techniques. This can be done in a matter of days rather than weeks or months. But the key here is the collection of the digital data, so they have an accurate representation of what they need to do. So again, that's in research stage, but it could be production ready at any time. And here's that small airport I told you about. That will open in 20 days, something like that. This is Istanbul Grand, and Istanbul Grand is massive, as you know. It's about 1 million square meters. They're opening in two stages. So the first one is in 1st of November, and it will accommodate 90 million passengers. By 2024, Istanbul Grand will accommodate 200 million passengers. That's massive. And what Istanbul Grand did, again, much like Varma 12 and Norconsult, was they used connected BIM from the start. They made a conscious decision to digitize and use centralized models to manage the project. What you can see at the top left is one of the world's largest 4D building information models. In that, there's over 30,000 activities that are tracked and managed. They also have over about 150 tablets on site, so the workers, the management, can go around and check all the different components of this absolutely massive project. You can see the bottom left there. The domes that are twice the size of the porter cabin have to be lifted up into place. That is done using the digitization of the project. So managers can walk along with a tablet, and they will know automatically what time that particular dome is going to be lifted up into place. And on the right there is one of the world's largest baggage handling systems. And you can see no clashes. In the building's information modeling stage, they detected something like 320,000 design clashes. When they got on site, because they had the advanced knowledge, there was actually physically only 500 that had to be rectified. That is a huge benefit and a huge saving in cost and time. And actually, Istanbul will open as scheduled, and 60% of airports are always late. So this is a great achievement. Okay, so I showed you about cloud computing, and I showed you about the digitalization of everything. The last part of the future of making things is extremely exciting. It's machine learning, or artificial intelligence and deep machine learning. We've had machines doing things for a long time now. So machines revolutionized the production line. They've been sitting there making cars, airplanes, and so forth for a long time. But these machines are relatively, they're dumb. They're heavy, they're expensive, and they're dumb. They have one task, they're dangerous to human beings, so we have to keep them in cages. And they do one thing. They put a screw there, they put a screw there, it moves on, another robot does something else. What if we could teach robots to be more intuitive? Well, we're doing that. This is our robot. This robot is called Bishop, and Bishop lives in the US. And we've been teaching Bishop to be intuitive and to understand real-world problems and to solve them. Bishop was lucky enough to be put on the Lego duty. So we gave Bishop a hand and an optical eye to see and started teaching him how to put Lego together. We didn't program Bishop to pick up Lego from a particular place. Bishop learned that it doesn't matter where I put the Lego, it will always find the Lego and put it on the map. That's great, but that could take a while. So what if we used cloud computing to speed up that learning process? We took Bishop out of the real world and put him into a computer game. So we decoupled him from real time, and as you know, computer time is a lot quicker than real time. So overnight, Bishop is in his little PlayStation game, and he's learning how to put Lego together in computer time. So overnight, he put together millions of pieces of Lego, which would never be possible in the real world. And very messy if you have children. What else does that mean? It means that Bishop has learned, and any other robot on the network through the cloud will know automatically what to do with the Lego. It doesn't have to learn, it just knows. All the information is downloaded automatically. Exciting? Scary? Maybe. I think it's pretty cool. Here's another robot called Ash. And Ash isn't playing with Lego. Ash is a worker. Unfortunately for her, she has to do the real work. So Ash was actually learning how to 3D print. And you'll probably see here, she's actually 3D printing the chair that you saw earlier. But she's not being told what to do by a computer model. She's put in a closed loop system, which means she learns as she goes along. So she becomes a lot more intuitive and thinking. We can take it a step further. We can put ourselves into the world of the robot using virtual reality and start interacting with the robot. One of the things I said about those manufacturing robots is that they're quite dangerous for human beings. You don't want to be hit by one. But using this technology, we can almost train Ash to be aware of us, to be conscious of her capabilities and limitations. And this is happening right now. Again, this is all in research, but this is coming along very rapidly. And there is Ash asking for milk or food or something. These robots are being used now to build a bridge over a canal in Amsterdam. They are 6-axis robots. They learn as they go along, and they weld as they go along. Again, you can see the lattice structures there that mimic nature, mimic the strength and efficiency of nature. And it goes further than that. If we go into the world of simulation, we can use machine learning to help us overcome those difficult issues. Computational fluid dynamics can be very expensive. You also need to be an expert in all the algorithms and mathematics. You can see here 2 analyses of this car. The top one is generated using an algorithm. The middle one is generated using a very expensive wind tunnel. What the algorithm has done is to learn how the wind tunnel reacts to objects. So we can now put any object in the algorithm. It doesn't have to know what it is, and it will simulate a wind tunnel. And you can see the bottom image there is the actual difference between a real wind tunnel and the computer algorithm itself. So very exciting times. So to leave you, the question is, where next? Well, we believe that data is the new fuel. But data on its own is pretty useless. It just sits there. We need to use tools, and we are using tools, and will use tools, such as generative design and artificial intelligence, to make the best use of that data for our businesses and for our personal lives. And that is the future of making things. We are dedicated to research the way that these technologies are transforming the way we live, the way we create, and the way we manage. Çok teşekkürler. Teşekkürler. And importantly, I've been asked to tell you that coffee and refreshments are served from where you came in. Please enjoy the rest of the day. And if you have any questions for me, I'm here all day. Thank you.